Welcome everyone! Today, I'm going to teach you about the unit circle. Now, what is the unit circle? Well, the unit circle is a circle with a radius of 1. By the looks of things, it must be confusing to just see a circle, a bunch of lines, a lot of numbers, we even got square roots involved all of a sudden. What's all this got to do with a unit circle? Well, it's actually about trigonometry, baby. See, the unit circle is a circle in a Cartesian plane centered at the origin 0, 0. Trigonometry, as you may know, is about the study of triangles, particularly right triangles. Now, you probably know what a triangle is, right? Three sides, all the interior angles equal to 180 degrees. That's easy. I'm going to tell you about the different sides of the angles in a given triangle, which is measured by degrees and radians, and how the unit circle is used to define the different trigonometric functions and to find exact values of the trigonometric ratios. Before I do all that, we haven't even discussed what an angle is, right? Well, is this an angle? Is this an angle? Is this an angle? No, that's an angel. This is an angle. To discuss what an angle is, I'll present you a short PSA by President Furry. Take it away, President Furry. My fellow citizens, my name is President Furry and I'm going to talk about angles. Well, an angle has a vertex and the rays forming the angles are called sides. Now, these sides are different. The initial side is the starting position of the ray, and the terminal side is the ending position. If the vertex is at the origin and the initial side is at the positive x-axis, then it is in the standard position. If the terminal side rotates counterclockwise, it's considered as a positive angle. But if the rotation is clockwise, it's considered as having a negative measurement. Now, this is something different. These are called quadrant angles. Excuse me. The terminal side of the angle in a standard position coincides with one of the axes, 90, 180, 270, and 360 degrees, then it is a quadrant angle. This has been President Furry with angles. Thank you for your wonderful service, President Furry. There's also another type of angle. These angles are called coterminal angles. Now, a coterminal angle can be positive or negative. If you want a positive coterminal angle, just add multiples of 360, and if you want a negative coterminal angle, just subtract multiples of 360.
Hold it! Objection!
Huh. Well, that was surprisingly informative. I didn't even know that there were trials about angles. Anyways, let's move on to a different topic. Let's talk about reference angles. Well, a reference angle is a positive acute angle from the terminal side and the x-axis. To find the reference angle, first we've got to find which quadrant the angle lies in. This is quadrant 1. In quadrant 1, only 0 to 90 degree angles are present. This is quadrant 2. In quadrant 2, there are only 90 to 180 degree angles. Next is quadrant 3, where you can only find 180 up to 270 degree angles there. Lastly, quadrant 4, where 270-degree angles up to 360-degree angles lie. If the given angle is in quadrant 1, then that's already your reference angle, just keep it as is. If the given angle is in quadrant 2, you first subtract the angle to 180, or 180 minus x. If the given angle is in quadrant 3, then you must subtract 180 from the angle, or the angle minus 180. If the given angle is found in quadrant 4, then you must subtract the angle to 360, or 360 minus the angle. Examples on reference angles. Let's call on Burger Bro. Come in, Burger Bro. Yo, my name's Burger Bro, brah. And I'ma teach you about reference angles, dude. Okay, so check it, man. This is 50-degree angle. And what my bra said? If it's in quadrant 1, man, calculation be gone, dude. It is what it is.
It is what it is. It is what it is.
Okay, so check out this next one though. This is just a 235-degree angle. As you can see, 235-degree is an angle that's in quadrant 3. Yo, that's lines, bro. Yo, but check it though. So 235 minus 180 equals 55 degree. And that's easy, bro. What was that, bro? A negative angle? Well, it's actually quite easy to do the negative angles, bro. It's actually just the same, to be honest. Well, since it's negative 160 degree, we can already assume that it's in quadrant 2. So, what are we gonna do, dude? To be honest, just disregard the negative. Or if you're more mathematical, just get the absolute value, bro. So, the absolute value of negative 160 is just 160. So, 180 minus 160 equals 20, bro. That's already your reference angle, baby, bro. Yo, so that's already all our examples here, bro. So, I'm just gonna go, dude. This has been Burger bro. So, back to you, dude.
Change the world. My final message. Goodbye.
Thank you very much for that, Burger Bro. Moving on to the next topic, I'm going to teach you next on how to convert radian measure to degree measure and how to convert degree measure into radian measure. But first, what exactly is radian measure? Well, 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc with the same length as the radius of a circle. Since the circumference of a circle is 2 pi r, then there are 2 pi radians in a full circle. 2 pi radians equals 360 degrees, and pi radians is equal to 180 degrees. Now, there is a formula for you to convert degree measure to radian measure. The formula is you multiply the degree measure by pi radians over 180. Now, I love calculations myself, so I'm going to do examples of this with you live. So, this is our first example. We must turn 35 degrees into radian measure. Now, how do I usually go on about that? Well, I usually just write down the formula first, which would be x multiplied by pi over 180 degrees. After I write down the formula, I usually just substitute the given, which would be 35 degrees. So it would be 35 degrees multiplied by pi over 180 degrees. Considering that 35 degrees is a whole number, we can just assume that there is a denominator of 1. So, yeah, it's a denominator of 1 already. Now, at this point, you just simplify. Now, we must remember that you can actually cancel out units, so we must cancel out our degree unit in order for it to be the right kind of unit. So, you must cancel the unit of degrees on 35 degrees and 180 degrees. Now it's just a matter of multiplying the number. So it would be 35 pi over 180, since 35 times pi would be 35 pi, and 1 times 180 would of course be 180. Now at this point you should think, can I still simplify this? And the answer is yes, you can still simplify by the multiple of 5. So, what would be 35 divided by 5 would be 7. But don't forget, you have pi, so it would be 7 pi. Now, what is 180 divided by 5? It would be 36, so over 36. And now, again, think to yourself, can I still simplify this? And well, if the answer is no, then that's your final answer. So the final answer is 7 pi over 36 radians. Of course, don't forget the unit, that's very important. And now we box the answer. So, this is our second example. You must turn negative 285 degrees into radian measure. Now, what should we do? Just like earlier, we write down the formula first. So, x multiplied by pi over 180 degrees. After that, write down the given. Negative 285 degrees multiplied by pi over 180 degrees. Divided by 1, since whole number. And now we just cancel out the degree units, so you don't have to take care of it later on. Now, there's a negative sign. What should we do about that? Well, we just carry on like it's normal multiplication. So, negative 285 pi would be our answer, and 1 times 180 would be 180. Now, always think, can still this be simplified? The answer is yes, by 15. So, what is negative 285 pi divided by 15? It would be negative 19 pi. And what would be 180 divided by 15? It would be 12. So, think again, can still this be simplified? And the answer is no. So that's already our final answer. So, write it down here. Bam, 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 bam. Radians, don't forget the units, by the way. Don't forget unit, that's very important. And that is our final answer. Yay! For you to convert radian measures to degree measure, it's practically the same thing. The formula goes as you multiply the radian measure by 180 degrees divided by pi radians. Now, like I said earlier, I love calculations, so I'm going to do another segment of examples. So, this is our first example in turning radian measure into degree measure. So, our first example is pi over 3, so we have to turn it into degree measure like I said. So, what should we do here? Well, similar to earlier, I like putting down the formula first. So, what is our formula? It would be x multiplied by 180 degrees over pi. Now after that, I just write down the given. So pi over 3 multiplied by 180 degrees over pi. Now I feel like this is actually easier than the other one, since all you have to do is just cancel, and now it'll just be 180 degrees over 3. So what would be our final answer? It would be just 60 degrees. That's actually really easy. So, this is our second example. We just have to turn negative 5 pi over 6 into degree measure. Easy enough. So, just write down the formula. X multiplied by 180 degrees over pi. Then, write down the given. So, what would be our given? It would be negative 5 pi over 6 multiplied by, what was our formula? 180 degrees over pi. After this, just cancel. So, negative 5 pi here. So, just cancel. Bam, bam. And what we have left would be negative 5 over 6 divided by 180 degrees. And of course, you should put in a 1. It's important. It's the denominator. Then at this point, you just have to multiply. So, negative 5 times 180, that would be negative 900 degrees. 6 times 1, of course, would be 6. Now again, think to yourself, can still this be simplified? And the answer is yes. Negative 900 degrees over 6 would be negative 150 degrees, and that is already our final answer. And there you go, it's actually just that easy. Now, remember the unit circle earlier? Well, here's a guide for you on the different radian measures for each angle. You might want to pause the video right now if you want to see each value for each angle. Okay, now let's loop back around to the unit circle because of course we've got to understand it further. I've already talked about how a unit circle is a circle with a radius of 1, easy enough. But there's different parts to it. See, a unit circle has a central angle, and a central angle is an angle whose vertex is at the center of the circle and its sides are the radius of the circle. To find the length of the arc that intercepts the central angle, you just multiply the radius to the angle. The length of the arc is also the radian measure of the central angle, theta. The radian measure theta of the central angle of a circle is the radius of the arc length, or s to the radius of the circle. To make it nice and simple, this formula is theta equals s over r. Now, I'm going to show you some examples. Hold it! Well, I want to do some examples. Fine. Jeez. You could have just asked, you know. First problem. We first gotta find the length of an arc that subtends an angle of 5 pi over 6 in a circle with a radius of 24 centimeters. It's actually pretty easy to do if you know the formula, which is s side multiplied by the radius and the angle, which is theta. Now, after this, you just gotta substitute the given with the formula, which would be 24 centimeters multiplied by 5 pi over 6. Now, after this is just multiplication, so 24 over 1 multiplied by 5 pi over 6. And now would be 24 times 5 pi, it would be 120 pi. And 1 times 6 would be obviously 6, like, my god. And after that, you just gotta think, can I still simplify this? And the answer is yes. So, 120 divided by 6 would be 20 pi. And after that, like I said, would you still be able to simplify this? And the answer is yes. 20 times pi would be 64.83 centimeters. And that is our final answer. Well, approximately our final answer, I guess. So this is our second question, and we gotta find the length of an arc that subtends an angle of 135 degrees in a circle with a radius of 8 centimeters. So first we gotta put 135 degrees into radian measure. So 135 degrees over 1 multiplied by pi over 180 degrees. So then we just gotta cancel the degree measure. And now it's just a matter of simplification. So 135 pi over 180, of course. So can still this be simplified? And yeah, by the number 45. So it'd be 3 pi over 4. And that is already our angle that we're gonna use in the formula, which is s equals r multiplied by the radius, or theta. After that, it's just a matter of substituting again. So it would just be, what is our radius? Our radius would be 8 centimeters multiplied by our angle, which is 3 pi over 4. So 3 pi over 4. After this is just a multiplying, so 8 over 1. So it would just be 8 times 3, which is 24. Don't forget pi over 4. What would be 24 pi over 4? It would be 6 pi. And 6 pi can still be simplified. Yes, it would be 18.85 centimeters approximately. And that is our final answer. So backs it up. Again, another surprisingly easy topic. Let's move on. Alright, so now that's out of the way, in the unit circle there are also coordinates involved. Now, here are the different coordinates in the unit circle. For 0 or 360 degrees, the coordinate is 1, 0. Remember, 360 degrees is also 2 pi radians. Next is 0, 1, the coordinate of 90 degrees, or pi over 2 radians. Then for the coordinate of 180 degrees, or pi radians, is negative 1, 0. Lastly, the coordinate of 270 degrees or 3 pi over 2 is 0, negative 1. To make things easier, there are also assigned coordinates for special angles. Pause the video now if you want to see the different angles. In order to get the angles of those that are not special angles, get the reference angle first. You can do that by converting it into degree measure and then get the reference angle there, then converting it back to radian measure. Now, this information is very useful for our next topic, finding the exact values of circular functions. Alright, in order to find the values of circular functions of a given angle, we are going to use the coordinates of the terminal point of the angle on the unit circle. So we're going to let p theta equals x and y be the coordinates of the terminal point of angle on the unit circle. We're going to use it to define the 6 circular functions of theta. I will now enumerate the functions one by one. There's sine theta equals y, cos theta equals x, tan theta equals y over x, cosecant theta equals 1 over y, secant theta equals 1 over x, and cotangent theta equals x over y. Keep in mind that cosecant, secant, and cotangent are inverse functions of sine, cosine, and tangent, respectively. You're probably asking, why can't x or y be equal to 0 for tangent, cosecant, secant, and cotangent? It's because that it would become undefined seeing as you can't divide by 0. Now, I'm going to show you some examples of finding the exact values of the 6 circular functions. So, our first problem would be to try and find the exact values of 6 circular functions of the quadrantial angle pi over 2. Now, our first step would be trying to find pi over 2 in the unit circle. So, where is pi over 2? It's right here. So, what's its coordinate? Its coordinate would be 0, 1. Now, this would be our x value and this would be our y value. Now, we already have a lot to work with here. Since we already have the different formulas and we have the coordinates, it's just a matter of substituting the given to the formulas. So what would be our sine theta? Sine theta equals y. So what is y? It would be 1. Easy. Cos theta would be our x is 0. So 0. So tan theta would be y over x. So what would be y over x? It would be 1 over 0. Now you can't divide by 0. So it would be undefined. So just write it undefined. Now, remember what I said earlier about cosecant, secant, and cotangent just being inverse of sine, cosine, tangent. We can just reciprocate the values of sine, cosine, and tangent, but since we have the formula, we just plug it in. So cosecant theta would be 1 over y, so 1 over 1 would just be 1. Easy enough. Secant theta would be 1 over x, so it would be 1 over 0, so it would be undefined. And then cotangent theta would be x over y. So what is x? It would be 0, y would be 1, so it becomes 0. Now this is actually pretty easy, so let's move on. So our next problem would be to try and find the exact values of 6 circular functions of the quadrantial angle negative 5 pi. Now if we try to find negative 5 pi in the unit circle, it would land in negative 180 degrees. So our value would be negative 1, 0. So this is x, this is y. So just substitute it to the formula. So sine theta would be 0, cosine theta would be negative 1, tan theta would be 0, negative 1, so it just becomes 0. Cosine theta become 1 over 0, so it's undefined. Secant theta would become 1 over x, so 1 over negative 1 would be negative 1. Now cotangent would be x over y, so negative 1 over 0, and we can't divide by 0, so it would become undefined. And that is actually it. It's actually pretty easy. I hope you find this video entertaining or informative, or maybe a bit of both. Now we're done with the unit circle. I'm outies!